Hello and welcome to the IDM2040 and LDSBus sensor demonstration video. Today we will cover the hardware used in this demonstration, the software and libraries utilised, as well as how to program the device. Firstly, we will discuss the hardware. There's an IDM2040 7A display. This intelligent display module features a 7-inch 800 by 480 capacitive touch panel. The module carries the latest generation E4 BT817 graphics controller and is supported by a low-cost, high-performance RP2040 microcontroller. There is an onboard RS485 transceiver which allows communication with long-distance sensor bus devices or DMX512 devices through a Cat5 or 6 cable over an RJ45 connector. The input power supply can either be a Type-C power delivery charger or a PSU via a DC jack. This is connected to our HVT junction. The LDSBus HVT junction connects LDSBus devices, sensors or actuators to the LDSBus. It serves as a data and power interface between the LDSBus host, in this case the IDM2040, and the LDSBus device. Each LDSBus HVT junction can connect up to 4 LDSBus devices. The LDSBus device we use in this demo is the CO2 sensor. The LDSBus CO2 sensor is a true CO2 sensor that features 4 sensors in a compact, low-profile design. It can include sensors to measure CO2 temperature, humidity, and ambient light. The CO2 sensor can be mounted on the ceiling or swivel-mounted on the wall. LDSBus CO2 sensors are compatible with BRT systems, IoT portal, panel, smart living, and LDSBus Python SDKs. Moving on, this allows us to discuss the software that will be used in this application. Firstly, we use CircuitPython to program the IDM2040 device. This is used in conjunction with the LDSBus SDK, which is available for CircuitPython also. The source code for the application can be found on the Bridgetek GitHub page, along with the Pico BRT Eve CircuitPython library, which adds support for the FT81X and BT81X series of Eve graphics controllers to CircuitPython. Navigating back to the LDSBus demo, we can see the LDS SDK firmware folder. In here we have the LDSBus SDK UF2 file, which can be downloaded and flashed onto your IDM2040 device. This can be achieved by holding the boot select and reset button, then releasing the reset button while boot select is still held should cause the RPi RP2 device to appear on your host machine. From here we can copy the UF2 file for the LDSBus SDK firmware onto the device. Once this is copied, the IDM2040 is flashed with the LDSBus SDK. Once this has been completed, a new CircuitPy drive will appear on your host machine. The next stage of programming the demo application is to download the BRT Eve library onto the IDM2040 device. We can download this from the Bridgetek GitHub page. Downloading the project as a zip file from the following link. Once downloaded, we can extract the folder and then navigate to the BRT Eve folder within the extracted files. Copying the BRT Eve file onto the CircuitPy drive on your host machine will install the BRT Eve library onto your IDM2040 device. There are a couple more files required to finish programming the LDSBus demo onto the IDM2040 device. If we download the LDSBus demo source code as a zip, and then extract this zip file, if we unzip this, we can navigate into the LDSBus folder within the extracted source code. From here we want to copy the JSON, UI/LDS and code.py files onto the CircuitPy drive. Once complete, the LDSBus demo has been successfully programmed onto your IDM2040 display, and you can use this demonstration in conjunction with an LDSBus HVT junction and any of the LDSBus sensors available. Finally, here we can see our hardware setup for our IDM2040 and LDSBus demonstration. Firstly, we have the IDM2040 display module. Connected to this via the RJ45 port and a Cat5 cable is the HVT junction. Connected to the HVT junction is an LDSBus CO2 sensor. To power the demo, we want to use a power delivery capable USB charger and connect this to the CN12 connection on the back of the display, ensuring that the W1 jumper is left unpopulated. Once the application powers up, it will start scanning for a sensor. Once the scan is complete, the sensor will appear in the device list of all connected LDSBus devices. We can rescan again via the scan button or view the sensor's properties via the UID button associated to this device. By pressing the UID button, it will bring up the sensor details for the connected sensor. As you can see, the application code has identified this as an LDSBus CO2 sensor. We can view more information about the sensor via the info button. The sensor has 4 outputs. It has a temperature reading, an ambient light reading, a CO2 reading and a humidity reading. If we wish to see more detailed information about one of these readings, we can press the associated graph. Pressing the back button will let us see all 4 sensor readings for this specific sensor again. Thank you for watching this IDM2040 and LDSBus demonstration video.